everyone. Let's solve this question on what we call density and pressure. Density measures mass per unit volume of a substance. And when it is pressure, that is when we have, it measures force acting normally per unit area. That is the cross-sectional area of a material. So in this case, we have a large man sit on a four-legged chair with his feet off the floor. Okay, you know what that means when his feet is not on the floor. Okay, now the combined mass of the man and chair is 95.0 kilograms. So if the chair legs are circular and have a radius of 0.500 centimeters at the bottom, what pressure does each leg exert on the floor? Like I said, pressure measures the what? The force acting normally per unit cross-sectional area of a material. So the goal here is for us to what? To calculate pressure. Fine, but we know that pressure can be measured as the ratio of weight acting per unit area, because the unit of weight and the unit of mass, unit of weight and force, they have the same unit of measurement. Weight is measured in Newton, same with what? Force. So first thing first is to what? Is to calculate the total weight of the man and the what? And the chair, because we are giving the combined mass of the man and chair to be what? 95.0 kilograms. So let's have our analysis or solution now. So the first thing, that's step one, okay, is to what? Is to calculate the total weight of the man and the chair. Okay, and that will be W. We know that to be W equals to the combined mass of the man and chair multiplied by acceleration due to gravity. So we know that G is what? 9.81 meters per second square. That is the value of G, acceleration due to gravity. Okay, so now we know that the mass of the man, which is a combined mass of the man and the chair, is 95.0 kilograms. So the combined weight, which is the total weight, will be 95 multiplied by 9.81. Don't forget that the unit will be what? Newton. So when we multiply 9.81 when multiplied by 95, the answer will be 93. So W will be equals to 931.95 Newton. So this is the total weight of the man and the chair. That's step one. Okay, since the chair has four legs, so which means the weight supported by each leg is what we're going to calculate next. Okay, because we know that there are four legs, so which means the total weight per leg will be when we divide this value of weight by the number of legs, because each leg will support the weight of the man, okay, by factor 1/4 times, multiplying 1/4 by what? By the total weight. And that's the same thing as what? The weight of the man and the chair. That is the total weight divided by what? By 4. So step 2. Now step 2 is to calculate the weight, okay, the weight supported, okay, by each leg. So we know that since the chair has 4 legs, it means that each leg support is 1/4 multiplied by, that's the product of 1/4 and the total weight of the man and the chair. This is the total weight. Okay, let's have that as WT. That's subscript. Okay, so in this case, so we have weight per each leg. Okay, that will be equals to the total weight. What's the total weight? Is what? The total weight is 931.95 0.95 Newton. Then we divide it by what? By 4. Because when this is multiplied by 1/4, it will be this value over what? Over 4. Okay, so when we divide the value by 4, okay, we're going to get the weight per each leg will be equals to 232, okay, 232.99, okay, Newton. So this is the weight per each leg. Step 2. Now, step 3. Remember, it is always good to analyze, when it comes to in physics, also in mathematics, it is always good to what? When setting up the problem, after we set up the problem, next to that will be to analyze the problem. So in this case, okay, so we have that and have a radius of 0.500 centimeters at the bottom. So that means the area of that's the area of the bottom of each leg. Yes, the area of the bottom of each leg. Yes, that's in this case. So we want to calculate the area of the bottom of each leg. And like what we have here, it is what? Circular. This is the radius. It is circular. So that means that we're going to use A equals to pi r squared. Now the radius, let's change the radius from centimeters to what? Meters. So what we have is 0.5, okay, 0.5 cm. That will be 0.5 times 10 raised to the power of what? Minus 2. 1 centi is the same thing as 10 raised to the power of minus 2. Okay, so let's bring it here so that this guy will be 3.142 multiplied by, so this will be 5 times 10 raised to the power of negative 3 raised to the power of what? All raised to the power of 2. So this becomes 3.142 times 25, then times 10 raised to the power of minus 6. So what is 25? Okay, 25 multiplied by 3.142. That would be 78.55 times 10 raised to the power of what? Minus 6. And this will be in square meters. So the area will be 7.855 times 10 raised to the power of 1 minus 6 in square meters. So the area will be 7.855 times 10 raised to the power of negative 5 square meters. So this is the area, okay, the area of the bottom of each leg. Of the bottom of each leg. So the next is to what? To calculate the pressure. What pressure does each leg exert? Yes, that's it. So step 4. So pressure, that is to calculate the pressure, okay, the pressure exerted by each leg, okay, because we have a 4-legged what? Chair. Okay, so the pressure exerted, we know that pressure, like I said, pressure measures the what? The force acting normally, or yes, normally per unit cross-sectional area of a surface. So we have this would now be weight per each leg. Okay, that will be weight over what? Over area. Weight over what? Area. So in this case, this will be this value. Okay, weight per each leg. Remember, this value will be equal. This value is 232.99 Newton. So we bring that here, and we know that area is what? 7.855 times 10 raised to the power of negative 5 square meters. So this would be 232.99, okay, over 7.855, okay, times 10 raised to the power of negative 5. Okay, so that this will be what is 232.99 divided by 7.855. That would be this guy. That will be 29.66. Okay, remember there's a 1 here, multiply by 1, And 1 is same thing as what? 10 raised to the power of what? 0. So, we have to bring the negative 5 up so that it will be positive 5. So that will be times 10 raised to the power of 5. So we move this guy. So this will be 2.97. Okay. When we move this, we move the decimal point to the power of 1 times 10 raised to the power of 5. Don't forget the unit of this guy, pressure. That's what? Pascal. Okay. So this is Pascal. Okay. And this will be 2.97 times 10 raised to the power of 6 Pascal. So the pressure, okay, is approximately, okay, let me leave it as 2.97 multiplied by 10 raised to the power of 6 Pascal. The noblest pleasure is the joy of understanding. Bye bye.